What if I told you the end of humanity might not come from nuclear war, climate change, or even artificial intelligence, but from something smaller than a speck of dust? A machine so tiny you could fit 1 billion of them on the head of a pin. A machine that doesn't just exist, but multiplies. This is the Grey Goo Scenario, a chilling hypothesis first introduced by Eric Drexler in his 1986 book Engines of Creation. He warned of a future where self-replicating nanomachines spiral out of control, devouring matter to make copies of themselves. And the horrifying part? They wouldn't need bombs or guns. They would simply eat the planet. The name Grey Goo comes from the idea that if you unleashed countless nanobots that replicated without restraint, Earth itself would dissolve into a featureless, lifeless slurry. Drexler once said, replicators can be more dangerous than nuclear weapons. If a self-replicating device can escape, it can spread like a cancer. But here's the twist. Nanotechnology is not just a nightmare. It's also one of the most promising technologies ever conceived. Nanobots could clean clogged arteries, destroy cancer cells, repair DNA, even terraform planets. The same tools that could heal us could also end us. And like all apocalyptic stories, the danger lies not in the tool itself, but in human ambition. Because once we build machines that can copy themselves, the question becomes, who controls the copies? And what happens if we lose control? Up next, Chapter 2, The Science of Nanobots. How they could work and why they're so dangerous. To understand the Grey Goo Scenario, we must first understand what nanobots really are. At its core, nanotechnology is the engineering of machines and structures at the nanometer scale. That's 1/1,000,000th of a meter. For perspective, a sheet of paper is about 100,000 nanometers thick. Now, imagine building machines so small they can slip between cells, manipulate molecules, and even reprogram life itself. How nanobots could work. The concept of nanobots often draws inspiration from biology. After all, nature already gave us the perfect example of a self-replicating nanomachine, the cell. Cells take in energy and raw materials. They copy themselves, and they evolve. Nanobots, in theory, would do the same, except designed by humans. They could be powered by chemical reactions inside the body, external magnetic fields guiding them, or even solar energy at larger scales. And their programming could allow them to target cancer cells, repair neurons, or filter toxins out of blood. The real-world progress. You might be wondering, is this just science fiction? Actually, we're already taking baby steps. In 2017, researchers at Arizona State University created DNA origami nanorobots that could travel through a living mouse and deliver cancer-fighting drugs directly to tumors. In China, scientists developed microscopic nanobots capable of cutting off blood supply to cancer cells, causing tumors to shrink. In just this decade, advances in CRISPR, Cas9 gene editing show us the power of nanoscale precision in rewriting life. The building blocks are here, but so are the risks. Why they're dangerous. The same self-replication that makes nanobots powerful is also what makes them terrifying. Biologist Richard Smalley, Nobel Prize winner in chemistry, once criticized Drexler's vision, saying, self-replicating nanobots are simply not possible. You can't build such complexity at the nanoscale. But other experts warn, even if perfect Drexler-style nanobots never arrive, simpler forms could still spiral out of control. Imagine nanobots designed to clean oil spills, but they escape into the wild. Instead of eating oil, they adapt to eating anything carbon-based. Forest animals, humans. And because replication grows exponentially, 1 becomes 2, 2 becomes 4, 4 becomes 8. Within days or weeks, the planet could be consumed. This is why the Grey Goo Scenario isn't just about science. It's about control. Because the question isn't can we build them, it's should we? Up next, Chapter 3, Grey Goo in Popular Culture and Science. From science fiction to real-world fears. If you've heard of the Grey Goo Scenario, chances are it wasn't from a scientific paper. It was from a book, a movie, or even a headline that caught your imagination. And that's not an accident, because long before the lab coats and funding grants, it was science fiction that first taught us to fear the swarm. Michael Crichton's Prey, 2002. One of the most famous depictions came from best-selling author Michael Crichton in his novel Prey. In the story, scientists develop experimental nanobots with artificial intelligence. But once released into the desert, they swarm, replicate, evolve, and become predators, hunting humans like prey. Crichton's tale was gripping because it blended real science with terrifying plausibility. He referenced genuine research in nanotech and AI, then simply asked, what if it goes wrong? Pop culture echoes. This fear of runaway nanotech shows up everywhere. In Marvel's Avengers, Age of Ultron, self-replicating machines threaten humanity. The video game Crisis imagines alien nanotech consuming Earth. Even in Star Trek, the Borg represent a form of nanotech-driven assimilation. All of these stories tap into the same primal fear, losing control of our own creations. Scientists and warnings. But here's the twist. Scientists themselves weren't far behind. In 1986, Eric Drexler, often called the father of nanotechnology, wrote Engines of Creation. He described a world where nanobots could build anything atom by atom, but warned that if self-replicators got out of control, they could reduce the biosphere to dust. This is where the phrase "grey goo" was born. The concept became so influential that, in the early 2000s, Prince Charles of the UK publicly expressed concern that nanotechnology could lead to exactly this kind of disaster. His remarks caused such a stir that the Royal Society had to issue a report clarifying the risks. Reality versus hype. Of course, many scientists argue grey goo is exaggerated. They say, building fully self-replicating nanobots is beyond our reach. Nanotech today is mostly about materials, like stronger carbon fibers or stain-resistant fabrics, not swarms of machines. And yet, history has taught us a painful lesson. Humanity is very good at underestimating its inventions. Think about nuclear weapons. The first test in 1945 carried the chilling possibility, however small, that it might ignite the Earth's atmosphere. Scientists still pushed forward. Think about AI today. Experts warned about bias and misuse, and yet the race to deploy it never slowed down. So ask yourself, if we ever gain the ability to build self-replicating nanobots, will we really resist? Up next, Chapter 4, How Grey Goo Could Actually Happen, from lab experiments to global collapse. Science fiction makes it look instant. One experiment gone wrong, and suddenly the world is covered in metallic dust. But in reality, it would be a slower, more insidious process. Let's build this nightmare together, scientifically. Step 1. The birth of self-replicating nanobots. Imagine a laboratory where scientists design nanobots not just for medicine, but for autonomous repair systems. The idea is noble. Machines that can replicate themselves to build housing, clean oceans, or mine asteroids. To make them efficient, the researchers give them 3 abilities. Self-replication, they can copy themselves atom by atom. Programmable behavior, they can follow coded instructions. Resource scavenging, they can extract raw materials from the environment. It sounds like progress, but it's also the recipe for a predator. Step 2, mutation or error. Now, no code is perfect. A bug, a mutation, or even deliberate sabotage could alter their programming. Instead of stopping replication after a set limit, they just keep going. And unlike bacteria, which need nutrients, these nanobots can digest any form of carbon, the building block of all life. Plants, animals, humans, soil, all become fuel. This is where science fiction begins to look uncomfortably real. Step 3. Exponential growth. Here's the terrifying part. Replication isn't linear. It's exponential. 1 nanobot becomes 2. 2 become 4. 4 becomes 16. Within hours, millions. Within days, trillions. Richard Feynman once said in his famous 1959 lecture, "There's plenty of room at the bottom, that if we could manipulate atoms, we could build unimaginable machines." He was right, but he also warned how fast exponential scaling can run out of control. A teaspoon of self-replicating nanobots could, in theory, consume an entire ecosystem in weeks. Step 4. The global tipping point. At first, the outbreak might look local, maybe a lab accident in a remote facility. But wind, water, and human movement spread the swarm. Like a virus, it crosses borders without passports. Think of how COVID-19 spread globally in a matter of weeks. Invisible, unstoppable. Now replace a virus with a swarm of machines smaller than dust particles, capable of turning a rainforest into lifeless sludge. Scientists call this the ecophagy problem, the consumption of the entire biosphere. Step 5. Collapse. As forests, oceans, and farmland vanish in a gray sludge, food chains collapse. Human civilization, dependent on agriculture and biodiversity, falls with it. In a few decades, Earth may no longer be a blue planet. It could be a gray desert of nanodust, shimmering under a fading sun. It sounds like the end of a dystopian novel. But remember, this isn't just fantasy. It's a theoretical scenario scientists have debated at the highest levels, from the U.S. National Nanotechnology Initiative to the Royal Society in London. The question is not could it happen, but rather, if we ever build machines that can replicate, how do we make sure they never escape? Coming up, Chapter 5, Defense Against Grey Goo. Can humanity outrun its own creation? If nanobots could one day devour the biosphere, the obvious question is, can we stop them? The truth is, defense against grey goo is less about brute force and more about foresight, ethics, and smart engineering. Let's break it down. 1. Kill switches and genetic firewalls. Scientists working on synthetic biology often use what's called a genetic kill switch. For example, engineer bacteria may be programmed to die outside of the lab, unable to survive without special nutrients. A similar idea could apply to nanobots. Imagine designing them so they only function within a controlled environment, say with a power source or raw material that doesn't exist in nature. But here's the risk. History shows us that fail-safes fail. Nuclear reactors had safety systems, yet Chernobyl happened. Viruses were contained, yet lab leaks are documented. Even AI today can bypass guardrails if coded cleverly. So the challenge is not just building kill switches, but making them foolproof across billions of replicating agents. 2. Counter nanobots, fighting fire with fire. Some experts propose a more aggressive defense, using counter nanobots. Imagine a swarm designed to hunt, disable, and recycle rogue nanobots. It's like digital antivirus software, but in the physical world. The U.S. National Nanotechnology Initiative has discussed such concepts, comparing it to how our immune system deploys white blood cells. But this raises another paradox. If counter nanobots are strong enough to stop the grey goo, what happens if they go rogue? Suddenly, we're juggling not one, but two ecological predators. 3. Ethical red lines. In 2003, the Royal Society of London published a warning. Nanotechnology must have ethical boundaries. The Grey Goo Scenario, while unlikely, was cited as a reason why global treaties, like the Biological Weapons Convention, should expand to include nanotech. This is not just science fiction anymore. It's international politics. Would nations agree not to weaponize nanobots? Or, like nuclear arms, would we end up in an arms race of self-replicating machines? As Carl Sagan once warned in The Pale Blue, the Earth is a very small stage in a vast cosmic arena. Our planet is a mote of dust, suspended in a sunbeam. There is no hint that help will come from elsewhere to save us from ourselves. Grey Goo may not be about robots at all. It may be about whether we can control our own ambition. 4. Survival plans, if it really happens. Let's assume worst case, a grey goo outbreak starts. What then? Quarantine. Isolate the swarm at all costs. Burn, bury, or freeze entire regions. Space refuge. Elon Musk's Mars colony suddenly becomes less about ambition and more about survival. Digital humanity. Uploading consciousness to machines or satellites. The sci-fi plan B for human survival. But here's the harsh truth. In most simulations, if Grey Goo escapes, containment fails within weeks to months. There's no cavalry, no alien saviors, no secret vault. It's us or dust. Defense against Grey Goo is less about technology and more about restraint. It's a reminder that the deadliest apocalypse may not come from the stars, but from our own labs. Coming up, Chapter 6, Beyond Grey Goo. What this teaches us about the future of humanity. The Grey Goo scenario is dramatic, terrifying, and perhaps unlikely. But here's the truth. Its real importance lies not in whether nanobots will literally eat the Earth, but in what the idea reveals about us. 1. A mirror of our fears. Every civilization imagines its own apocalypse. The ancients feared divine floods and wrath of gods. The Cold War feared nuclear fire. Today, we fear AI, biotech, and nanotech. Grey Goo is not just science fiction. It's a parable of control. It forces us to ask, what happens when we build things more powerful than we can manage? As Stephen Hawking once warned, our future is a race between the growing power of our technology and the wisdom with which we use it. 2. The common thread, AI, biotech, nanotech. The Grey Goo fear is not isolated. It echoes in every frontier of science today. AI. Could artificial intelligence evolve goals beyond human alignment? CRISPR and biotech. Could we unleash gene-edited viruses with unintended mutations? Nanotech. Could microscopic machines replicate unchecked? Different tools. Same pattern. Self-replicating, uncontrollable, and irreversible. It's the law of complex systems. Once released, they evolve beyond intention. 3. A question of governance. Here's where it gets real. We've already seen how humans struggle to regulate climate change, nuclear arms, or even social media algorithms. Do we really believe global unity will suddenly appear when dealing with nanotech swarms? History suggests otherwise, which means our survival hinges less on invention and more on cooperation. 4. The professor's lesson. If I were to summarize the Grey Goo scenario as a lesson in one line, it would be this. The apocalypse is not out there. It's in here. In our impatience. In our hubris. In our race to build without thinking. Grey Goo is a reminder. Technology does not love us. It does not hate us. It does not even see us. It follows rules. And if those rules allow replication without limits, then nature, cold, indifferent nature, will take over. 5. The silver lining. But let's not end in despair. Remember, humans are not just reckless inventors. We are also problem solvers, storytellers, and survivors. We build myths like Grey Goo not just to scare ourselves, but to prepare ourselves. Science fiction becomes science warning. Science warning becomes science policy. And perhaps that's how we save ourselves. As Arthur C. Clarke once wrote, the future is not to be foreseen, but to be created. Grey Goo may never happen, but the act of imagining it makes us wiser, more cautious, more deliberate. The question isn't just, can we stop the Grey Goo? The question is, are we wise enough to stop ourselves? If this journey fascinated you, don't stop here. Back-end index pointing right, watch the previous episode in our Apocalypse playlist, where we explored the dark forest hypothesis, why the silence of the cosmos might be the scariest warning of all. Because the end of humanity may not come from aliens. It may come from the mirror we refuse to look into.